This is a video that will just summarize what we've learned so far about the 4 types of substances. So if you're following along at home, you can get a blank piece of paper and make a little chart. We're just going to chart these out so it all makes sense. Our types are going to be elements. This is very informal, isn't it? Ionic compounds. All right. Acids. And then molecules. All right. Okay. Hope you can read my writing. And here we go. So elements are pretty basic, right? We all know what elements are. But the only thing to remember is 7 are diatomic. And diatomic, of course, means 2 atoms, right? And we also sometimes refer to these as molecular. And if you think about what they are, there are 7 of them, right? They're all gases at room temperature. And if you think about what that means they're all zinging around and colliding with each other. And then they're all also, interestingly enough, they're up in here, except for hydrogen. Hydrogen's way over at the far left, right? But if you think about where they are, they're all here in the most electronegative area of the periodic table. And therefore, they have typically 1 to 2, and sometimes 3, open spots on the valence shell that they want to fill quite desperately. And so because they're typically gases, and because they're so electronegative, they do form up, they hate being by themselves. When they're by themselves, they're actively looking for another element to join up with. And typically there's another element of the same type in the area, another atom of the same type in the area rather. And so they join up there, and so they're always in groups of 2. So if you think about what they are, know that you will always see them together. Have no fear of ice cold beer. But we said, wait a minute, that wasn't quite right. We do need to be a little bit afraid of the cold beer, because these are chlorine and bromine, right? So they're the only ones that have a total of 2 letters in their atomic symbol, right? And we know that whether we've got something like oxygen that's diatomic, or whether we've got another element that's completely by itself, that we can always assume that they have a charge of 0, okay? All right, now we're going to assume if we ever see Fe, and Fe is all by itself, that atom is not ionized, all right? He's a neutral compound. However, one thing that we do sometimes see, and here I'll just do bromine real quick, is if I have a charge, then that means it has ionized. All right, and that charge could be negative, like in this bromine example, or I could have a positive charge, right? And if I have a negative charge, we call it an anion. If I have a positive charge, we call it a cation, all right? But both of these we refer to as ions. Okay, so you have to pay attention to whether you've got any sort of charge indicator. And if you don't have a charge indicator, you're definitely always assuming that an element has a 0 charge when you see it. All right, so that's elements. Now let's move on and let's do ionic compounds. The important thing to know, and this is absolutely critical in chemistry, is an ionic compound consists of a metal joined with a non-metal. So let's just review real quickly what exactly we're talking about. Our metals start here, okay? So if you look at this, and you'll always have this with you on tests, right? That this is called an alkaline metal, right? In our first column, we know that that column always ionizes to a +1 charge, right? Our second column is called an alkaline earth metal. It just says alkaline earth there, but that's a metal as well. And we know this second column always ionizes to a +2 charge. And then if we come over here, we can find, for example, aluminum. And these guys are called the basic metals in our green. And they're always going to ionize to a +3 charge. All right, so it's sort of strange, but we're skipping. This is column 1A, ionizing at a 1. 2 is ionizing at a 2, +2. And then over here in our column, we're ionizing to a +3. All right. And then, so these in the greens are all considered metals. And look, way over here is tin, right? Over here is bismuth. Here's lead, right? So we're metals from here all the way across. All right, now the other thing we need to keep in mind is we've got this group in yellow, right? That's at this lower level, starting with energy level 4, or actually it's 3D, isn't it, right? And we can see that these are all in yellow. These are called the transition metals. And what we have to remember about those is they can ionize to more than one possible charge. And all of the ones that we need to be aware of, you have already documented on your table that you created. All right. So you should have a table that's got a legend. So you're always able to look here and say, yeah, there's copper ionizing to a +1 charge or a +2 charge, for example. Okay. So let's go on with what these are. When we name these ionic compounds, we're always going to name a metal, non-metal-ide. Okay? And because we've got a lot of them that can only ionize to one possible charge, right? Everybody in column 1, everybody in column 2, and everybody in column 3 that we work with, we know that they're automatically assuming a certain charge, right? And our nonmetals over here go from the ones in blue, so carbon and silicon, boron is as well, and we go on down through here, and we know that these guys always ionize in a predictable way. So we know there's no ionization going on here with our noble gases, right? Because their valence shells are completely full. Their electron valence shells are completely full. We know fluorine and on down always ionizes to a -1 charge. Oxygen and on down ionizes to a -2 charge. Nitrogen on down ionizes to a -3 charge. Okay, and those are my non-metals. So I can find these simply by sight and by looking at my periodic table. We know too that these non-metals are sometimes polyatomic. Right? And we've got all those that end in 8 to keep in mind of, right? Like, for example, the sulfate ion, right? You have memorized all the ones you need to know there. You know, of the metals, the only polyatomic that we need to worry about is our ammonium, right? Everybody else has a negative charge on them. And we know we've got the hydroxide ion, right? We've got the acetate ion, and then all the 8s. So we've got those. The only other thing we need to know about ionic compounds and their naming is our transition metals. And let's talk about how we name those. Okay, so for example, if I've got nickel, all right, nickel, if you look at your table you created, it can ionize to a +2 or +3. And therefore, when it's by itself, I may say nickel +3, right? That's an ion, right? But when it combines with oxygen, right, it's going to form nickel oxide. I can say, well, if I know this is a +3 charge and oxygen's -2, then I need to balance out these charges. Because one of my big rules is ionic compounds must be balanced. Be balanced in their charges. To equal 0. Right? So if I'm sitting here with a nickel ion at a +3 and oxygen at a -2, I've got to do what we call a switcheroo, right? Because I've got to balance out the charges. And this is the only way to do it. This 2 becomes a positive down here. This 3 moves down here. When I do that, I see that my nickel, I have 2 of them. Each of them has a +3 charge. So now I've got a total charge here of +6. When I look here at this oxygen, I say I have a -2 charge on each atom. I've got 3 total, so my total charge becomes a -6. So +6, -6. I'm balanced. I'm 0. Okay, so we need to have them balanced. And then the other thing is, and this is true of any ionic compound, must be balanced. Okay, not just the transition metals, right? But the only other thing you need to know is when I write down nickel, when I name this compound, I've got to call it nickel 2 oxide. And when I do that, I have indicated what my nickel has, +3. Sorry about that. I have a +3 charge on it, so it's nickel 3 oxide. Okay? So with all of my ionic compounds, names typically just metal, non-metal-ide, because everybody in chemistry understands that they must be balanced, and therefore unless it's a transition metal, we just can look and automatically know how many atoms of each substance is present. Okay, all right, next let's look at acids. All acids' name starts with an H, and that's how we identify what an acid is. The basic naming convention will vary. So if I've got an acid that only has one element, then it's going to be hydro. I have to have the hydro there. And then in this case, sulfuric acid. So I've got an ic acid. Because I only have one element here, I've got a hydro. As compared to, let's say I've got a polyatomic. All right? Okay, so here's polyatomic. Then this guy's going to be named sulfuric acid. All right, I still have the ic and the acid. The lack of having a hydro lets me know that there's a polyatomic ion here. All right, okay. And then acids must be balanced to 0. And again, just the simple name of it, and I know it's an acid, and therefore I must do the balancing myself. So I have an audience when I name it that intuitively understands the sulfate ion is a -2 charge, and therefore it's got to be H2, right? +2, -2, and balance it. All right? Okay, so that's acids. And next we go to molecules. And molecules are, whoops, I didn't write this very well, sorry. Non-metal plus non-metal. All right, so there's no metal present in a molecule. All right, and it doesn't necessarily one, it could be several. And so I'm always, when I talk about molecules, I'm always over here in the blue and this pink in my periodic table. All right, no metals at all are involved in this. Okay, and they make all sorts of different combinations. And that's because they're sharing their electrons, their valence electrons covalently. And we have no way intuitively, if I tell you that I've got carbon and oxygen and they're in a compound, I need to explicitly tell you what compound it is, because it could be carbon monoxide, it could be carbon dioxide, or it could be a sugar that also has something else involved, C6H6O. H1206, all right? So I need to be really explicit in my naming convention here so that you really get the sense of what it is. And therefore, what we do is we use prefixes. And they're used to get the number of that particular atom. And so we've got carbon dioxide. All right, so you need to have memorized the whole list of 1 through 10 of what these prefixes are so that you can know what everything is. Most of them are pretty obvious to you. And the only other naming convention that you need to keep in mind is that we have a naming convention of mono, but we never have that when we're starting off the name of something. If there's only one, like you can see here in carbon dioxide, I've only got one carbon, we don't say mono, but we do say carbon monoxide. So if the second or third, any subsequent element in the name has only one atom of that particular substance, that particular element, then we will use a mono in, but only then. All right? And then the other thing to keep in mind, we don't ever need to balance these. All right? So molecules, we do not balance, right? What molecules do you need to know off the top of your head? Well, you certainly need to know H2O, right? You need to know CO, you need to know CO2, all right? And then you need to know the diatomics, right? That we've already listed over here in our elements. But those are the major ones. Oh, be good to know sugar, right? But in general, we'll give you the names of any molecules that you need to know the name of. If you see carbon at the first, you're going to always assume it's a molecule and not a compound, all right? That one sometimes throws people, but carbon is always going to be part of a molecule. All right, very good.